All right, folks, we are now at the home stretch. This is the last piece we need to implement in order to glue all of this together. We need to implement our SQS worker so that we can read messages off of the queue and call our report builder so that it can construct the report from the Legend of Zelda API and write it to S3. Do me a favor before we jump into it. If you're finding these videos useful, do me a huge favor and like the videos and consider subscribing if you want to see more content like this. All right, so let's get started on implementing our SQS worker. All right, so to get started, we're gonna create a new worker file in our reports package. So what we're gonna do is have a new type that holds all of our dependencies so that we can implement methods to handle all of this processing logic. So let's do type worker. We're gonna need a reference to our application config. So we're going to need a reference to the report builder. We've got to import this. And let's go ahead and add a structured logger. This will be a slog. And we're going to need a reference to the SQS client. And we're also going to need a channel that can accept a SQS message type. This is actually going to be an AWS package SQS message type, not the one that we've built custom for our business logic. So this will be types message. And you'll see this is from the SQS package types. It has a bunch of SQS message attributes. The body is going to be the string value. That is our JSON that we've published, and we'll marshal it back into our own type. Okay, so I'm going to go ahead and create a new worker that will accept all these parameters. SQS client. And then what we're going to do is pass those along. Okay. And for our channel, I want to pass in a concurrency limit. Let me explain how we're actually going to be using this channel. We're actually going to be receiving messages through the AWS SDK that are our SQS messages, and we're going to be publishing them into this channel. And then we're going to have several Go routines reading off of this channel so that if we wanted to, we could have several messages be processed concurrently, and we can control the amount of concurrency via a parameter. So what I'm going to do is provide max concurrency here, and it'll just be an integer. And I'm going to make this channel be buffered up to the max concurrency. So at any point, if there's messages still on the channel that need to be processed, I'm not aimlessly or mindlessly retrieving more messages from the SDK. Okay, so what we're going to do first is implement a start method on our worker. What we're going to do is retrieve the queue URL using the SQS name. So let's go ahead and do that. All right. What we need to do is provide a context here. Okay, so we've got this queue URL input. We've seen this before. We're just going to grab the queue name. Okay, so we're going to need to return an error from this start method. Let's go ahead and handle the error. Okay, and I'm going to go ahead and add some logging here, just indicating that we're starting the worker. Okay, so the next thing we want to do here is create a number of Go routines that matches our max concurrency. And we're just going to go ahead and create a function that's running in the background. I want to pass the current index as an ID, just for logging purposes. And what's going to happen on the inside of this Go routine function is we're going to have a sort of infinite loop that is running a select statement. And there's going to be two conditions in the select. We want to make sure that we're heeding the context. So if the context is canceled or is done at any point, we want to stop processing. And then we're going to have another case on the select that is actually reading messages off of the queue. So let's go ahead and add that. We're going to handle our context done case, and we'll just log at this point. I'm going to call this go routine ID. And we'll return. And then our next case is reading a message off of the queue. And what we're going to do here is I'd like to have some helper method that I can just provide the message to, and it will do all of the logic we need. So I'll pass in a context. I'm going to pass in the message. And we're also going to need to provide the queue URL. So let's do queue URL output, queue URL. At this point, if there's an error, we're just going to log it. Failed to process message, go routine ID. That looks good to me. Okay, so now we've got our consumers set up. Let's work on our producer logic. And by producer, I mean we're going to be reading SQS messages using this client, and we're going to be sending them into the channel so that our consumers can read off of the channel. So I'm going to have an infinite loop here, and we're going to do SQS client receive message. We'll pass in our context and this receive message input. We, of course, need to provide our queue URL. And we can provide the max number of messages among some other items in here, which I'm not going to worry about at this time. Max number of messages, I will do our concurrency +1, just so that we can have some items on the channel to be consumed before we need to receive more messages, just to have a little bit of extra buffer room there. Okay. Let's go ahead and handle the error. I'm only going to log the error at this point, and the only scenario I want to break out of this infinite for loop is if the context is done. So I'll just go ahead and check if context error is not equal to nil, we'll just return. Okay, so the next thing I want to do is just double check that we have messages. Let's say if the lane of output messages is equal to 0, just continue. Otherwise, we can go ahead and start iterating over this loop. And we're just going to publish the message into the channel here. Okay, so now we've got our producer logic set up. We've got our consumers set up to read off of the channel and process the message. Now we need to implement this process message private method. Okay. First thing I want to do is do some custom validation. So if like the message body is empty, let's just return an error. If message body is equal to nil or is equal to empty, let's just return. I'm actually just going to slog it. And provide the message ID. And I will return nil because if we return an error here, this message would be picked up and retried again. Another thing we could do at this point is directly delete it off of the queue, but this will work for us. Okay, so now I want to actually I want to go ahead and marshal the message into our custom type, and then we'll do SQS message, which if you'll recall, it's our custom type that is a user UUID and a report UUID. Okay, so we're just going to unmarshal, handle the error, and I'm going to copy the same thing here. And I'm just going to say the message body is invalid because it couldn't be marshaled into our expected type. And we're going to do the same logic here, just return nil. Okay, at this point, we expect that our payload is valid. So we can go ahead and pass this information to our report builder. So let's go ahead and create a context to handle the max processing time for this report. And let's just say for this, it shouldn't take more than 10 seconds. And I actually want to rename this to builder context. And we can defer this cancel. Let's say builder, build. I'll pass in builder context. We're going to pass in message.user ID, message report ID. And we'll get a report back, which we probably won't do anything with this, but this could be good for testing purposes. So for now, I'll just leave this here. And at this point, if we have an error, I'm going to actually return that. Okay, and if we are successful, we can go ahead and remove this message from the queue. So let's do SQS client delete message. And we'll use the queue URL and receipt handle, yes, is the message receipt handle here. So let's say if, this returns an output as well, which I'm not going to look at. So we'll just do this and then say error. Say if error not equal to nil, then we'll just return. Okay, that looks good. Oh, these are pointers, so make sure we're referencing those so that we don't get ugly output here. Okay. This looks good. Let's, of course, return nil. Looking good so far. I think we can now go ahead and create our main file. So let's go to CMD. I'm going to create worker main.go. And this will be a main file. We're going to have a func main. And we're also going to have a run function, and it'll return an error. So now I can say if error is not equal to nil, if error not equal to nil, log fatal. And here we can go ahead and construct all our dependencies and run the worker. So let's do context cancel. And I actually want to do signal.notify context. And we'll just pass that as the signal. And let's see what our worker requires again. So we're definitely going to need our config. So let's do that. Handle the error. Okay. And we're also going to need an AWS config. Load default config. Make sure I have this context here. Okay. And we are going to need our store for sure. And that's going to require a database, so let's do that. Okay. And I'll go ahead and shift this around. And I'll go ahead and copy the code that we need from here to construct the S3 client. The SQS client as well. And I'm going to construct the report builder. It's going to take in the config. It's going to take in the report store specifically. The Legend of Zelda client. Let's go ahead and create that. And it will take in an HTTP client. And we can just set a timeout of second times 10. We can just say the timeout is 10 seconds. Let's go ahead and pass in Legend of Zelda client, S3 client, and our logger. I'm going to copy the logger from over here. And so we've got our worker. Okay, and it takes in a config. It'll take in the logger. It'll take in the SQS client. And it will take in a max concurrency. Let's say it's 2 for now. And we've completely forgotten one more item, which is the builder. Report builder. Okay, so now we've got all this set up. I can just say if error worker start, pass in the context, check if error is nil, otherwise return an error here. Okay, so this looks good. We should be in good shape to run our worker and make sure that it can receive messages. And before we start running the worker, I want to just make sure that we have sufficient logging in all the places that we care about. So I want to go in here and just mention that we are processing message with the message ID. And I actually want to make a slight modification here. If this is returning nil, the message will never get deleted. So I actually kind of want to handle this outside of this helper method. And I'm going to remove this here. And what we can do is just do that here. I will just say continue at this point. And we will log the error. Okay, so if there's an error in processing, we'll just log it and then continue. Otherwise, we can go ahead and delete the message from the queue. The other thing I want to do is log each go routine. Okay, so this looks pretty good. Let's go ahead and do go run CMD. Wow. We already had messages in the queue, and looks like the report was generated successfully. I did not expect this to work first try. Amazing. So what I'm going to do now is run the API server and retrieve one of these items. But first we need to log in. Sign in. This one gets us a report. That's good. Let's replace the JSON web token here. Okay, and then we need to also replace the report ID. So this one says it generated the report. Boom, look at that. We've got our report type, output path. This is the S3 path, and it's created at. We do not have the download URL though. What's up with that? Status is completed. Okay, let's check. Check the handler. This looks like a bug here. So if the download URL expires at is already nil, let's say I'm actually going to delete this logic for now. We can worry about this later. Let's say, and if it's completed at is not equal to nil, then let's just do this. I'm going to restart the server. And let's rerun it. And now we've got these fields. Okay, we can fix that bug later. And so now we've got this download URL. Let me do this. I'm going to do curl. Let's wrap this in quote. Oh, man. Wrap it in quotes because it's a weird URL. And then let's write it to file.gz, file.csv.gz. Okay. And let's do gunzip file.csv.gz. And let's just do cat file CSV. Boom. We've got the whole file in here. So cool. That's all you got to do is you just unzip the file and it's there. So let's fix this bug. If the report completed at is not nil, I do want to execute this path. And then I want to check if report.download URL is equal to nil. Or let's just say needs refresh. Let's say if the report is equal to nil or it needs refresh, then we can do all this logic, which I don't love this branching, but this looks okay. So actually, yeah, we could put this all in one line, but whatever. This looks good. So this should do the trick. We now have a working async report. I was completely blown away that this actually had messages in it and was ready to process them. But that was pretty awesome. All right, folks. So we now have this whole thing working end to end. A user can log in, sign up, refresh their auth tokens. We can generate a report that publishes a message to the SQS queue, and the worker will pick it up, fetch some data from an API, generate a CSV, load it into the S3 bucket, and the client can now download the report via a signed URL. We've got our worker working end to end. We've got the API server returning the completed responses. Let's talk a little bit about like when you would want to use something like this. In this example, I don't actually need this SQS worker at all, and I don't need to actually process this async because this report completes probably in like less than a second. You know, we're just retrieving data from an external API, writing it to a CSV and uploading it. This would be very quick to do in a typical request response synchronous API. You might want to do something like this if you have something that's going to take a long time to generate. So if it's going to take like 30 seconds, more than a minute maybe, to process this, you may want to start considering doing something like this where the client would want to pull and just wait for the background task to complete. And that might be a better user experience. There's, of course, a lot more stuff we could do with this API. We could still deploy it. We could set up rate limiting. We could also finish writing unit tests for the rest of this, but a lot of that probably isn't super interesting. But I may save stuff like that for later videos. This seems like a good stopping place. We've got this whole thing working end to end. I appreciate you guys sticking around till the end and watching all the videos. If you wouldn't mind liking all the videos and subscribing if you're into this kind of stuff, I'm planning to make a lot of cool stuff in the future, so make sure you stick around and turn on notifications for more content like this. Until the next one, I'll see you guys. Take care.